In this tutorial, we're going to cover anti-collision basics. I've already made an offset well near our planned well, so we can focus on the anti-collision versus spending more time on the well creation process that we did in tutorial number 1. The blue well is going to be our active well that we made in tutorial number 4, and the orange well is going to be our offset well that I put together for this tutorial. Now, these circles represent the ellipse of uncertainty, and if there's two well bores that are in close proximity and their ellipses touch, that means your separation factor is at or below 1. Now, your ellipse of uncertainty tends to increase as your measured depth increases. So you can see here in the plan view that at TD, our ellipses are the biggest that they're going to be for these wells. But as we travel up the well bore closer to the kickoff point, the ellipses start to go down in size. So to run any collision in directionalplan.com, first you'll select your reference well that you want to compare your offsets against. You'll click on offsets and you'll choose the offsets that you want to run your AC against. In this case, we're choosing example well number 2, which was the orange offset well that I showed at the beginning of this video. Now, when we look at the center to center graph, all this is showing us is the physical distance between the two well bores. It's useful for understanding spacing, but it doesn't account for the survey uncertainty. So you can see at surface, our spacing is about 40 feet from wellhead to wellhead. And as we drill, it increases up to 600 feet. And finally, once we get into the lateral, it settles out around 170 feet from the offset well bore. Now, when you go to separation factor, you can see that the separation factor at the beginning of the well, when the measured depth is shallow, is pretty high. It starts to decrease to around 3 as we start drilling vertically, but then as we start getting some separation, you can see your separation factor increasing again around 4,000 feet measured depth. Now, one thing I want to point out is that towards the end of the well, our center to center distances stay consistent around 160 feet worth of separation. However, since our measured depth is continuing to increase, our ellipse sizes are continuing to increase. And when our ellipse sizes increases, our separation factor decreases to the point where it drops below our 2.0 warning level and our 1.0 critical level, eventually reaching a minimum of 0.74. Now, the warning and critical thresholds can be adjusted here, where you go to profiles and settings. There's also an ellipse sigma level and the safety factor multiplier, which control how conservative the analysis becomes. Most companies choose 2 for the ellipse sigma level, but different operators will vary on what they want to choose to use. Now, different survey tool codes will produce different size ellipses. And if you want to change your tool code, you go to Well Actions, Well Settings, and then Edit Survey. In this screen, you click on your survey tool drop down and you could choose one of multiple tool codes that are saved into the software. In this case, we're going to choose MWD plus IFR plus MS. We'll go back to our separation factor and we'll notice that the minimum separation factor jumped from a 0.74 to 0.94. You can get a good visual representation of this by going to plan view and toggling the ellipses. You'll notice that the ellipse size on the blue line, which is our reference well, is significantly smaller than the offset well that's still using the standard MWD tool code that we were using before. We could do the same thing by going to 3D view. We'll adjust our camera so we can see our laterals more easily. We'll zoom in and we'll toggle the ellipses. And you can see the blue line, which is our reference well, the ellipse on it is significantly smaller than the offset well that is still using the standard MWD. Now we're still failing in a collision because our separation factor was below a 1. So what we're going to do now is we're going to go to the example well number 2, which is our offset well, and do the same thing. So we go to Well Settings, Edit Survey, and we're going to change this tool code to MWD plus IFR plus MS, and we'll save that reference system, save the changes. We'll go back to our example well number 1. We'll go back to separation factor. And now you'll see that by changing the tool code on the offset well, it increased our minimum separation factor from a 0.94 to 1.28. If you go to plan view, you can get a visual representation of this because our ellipses are no longer touching. Therefore, our separation factor will be above 1. We can do the same thing in 3D view, where when we toggle the ellipses, you can see that our separation factor is above 1 because our ellipses are no longer touching in the lateral. Another thing that can have a pretty big effect on your ellipse of uncertainty are your magnetics. So to change your magnetics, you go to Well Settings, go to Edit Survey, and it'll take you back to the Well Reference System screen. Now the Auto button assumes an IGRF magnetic model. It uses your surface hole location combined with today's date, and it'll determine what your magnetic declination is, your magnetic dip is, and what your field strength is. If you want to change these, you'll click on the Manual button. If you want to use the IGRF model on a different date, just adjust the date here, and the magnetic values will be automatically updated with the reference date. If you want to change your magnetic model, you'll go to Model, you'll click on User Defined, and you'll adjust the model name and enter in the associated magnetic values that came along with that model. So for this example, I'm just calling it test model. I'm gonna take my field strength and adjust it to 100,000. I'm gonna go to save reference systems, close out of this, go back to my separation factor, and you can see by increasing the field strength, it increased our separation factor from 1.28 to 1.35. Now, before moving on, I do want to point out that it may be tempting to just adjust the magnetic parameters and the survey tool codes or the anti-collision settings just to improve the separation factor. However, these values should always be based on sound engineering assumptions and available data. The anti-collision analysis should be used to evaluate and improve the well design and not to manipulate the inputs until the results appear acceptable. The last thing we need to do is create an anti-collision report. So we'll go to reports, click on create AC report, and then click generate report. And what this will do is it'll make a downloadable AC report straight from your browser, showing the minimum separation factors and center to center distances in 100-foot intervals, also highlighting any depths that drop down below the warning zone that were set in our user settings earlier. So now that we've covered anti-collision basics, the next step is adding context to the well plan. In the next tutorial, we'll look at annotations, lease and polygon boundaries, and formation tops, and how they can be used to better visualize the drilling environment and communicate important planning information.